So hi everybody, today we're going to make sure that we know how to do electron configurations. So to do this, we're going to need to be able to look at a periodic table Okay, so I've gone ahead and superimposed a picture of the periodic table on here so that we can use it while we work. And so I'm going to go ahead and recognize for you that osmium is right down here in the lower bottom of the middle of the periodic table. So maybe you can see that there. And so we're going to go ahead and count out exactly all of the electron configuration of osmium. And remember, we always start from the beginning. So this is going to be 1s2. And to get the 2 in the upper right hand corner, you're going to press Control and period at the same time, and that's going to give us 2. So then I'm going to go 2s2, and then I'm going to do, to go back, you press the Control and period again. So now I'm going 2p6, and then 3s2, and 3p6. And right now I have gone all the way across here to 2p6. I'm at 3s2. I've gone across to 3p6. Now I'm beginning at the 4s2 location. So I'm at 4s2, followed by, remember, it goes to 3d10, and I continue on. I'm at 4p6, and continuing on, I'm at 5s2, and then continuing even more. I am now right here where yttrium is, and so I'm going to the 4ds next, 4d10, and then 5p6, and then I'm at 6s2. Right after 6s2, and before we start the 5ds, we have to fit in all of the 4f14s. So I'm going to fit in 4f, let me make sure that's bigger, 4f14, and then I go to 5d, and I need to count my way over to osmium, which is 1, 2, 3, 4, 5. It does show me as 5d6. Okay, and so that is osmium. Now, if I need to show this as, or identify what is my highest energy electron, my highest energy electron is always going to be that final set of electrons that I put down. So I'm going to type in 5d6 as my highest energy electrons. And since I'm here, let's go ahead and answer the question about what is the number of valence electrons. You might notice that my outermost energy level is on the 6th energy level, so my number of valence electrons is 2. Okay, after you note the number of valence electrons you have, which can be found in the outermost energy level, then you need to show the noble gas abbreviation. And please remember that the noble gas abbreviation begins with some brackets, and inside the brackets is the noble gas that is the most recent noble gas within your electron configuration. So you're always looking for the part of the electron configuration that ends in p6. That's going to be your most recent noble gas. And so the noble gas that exists at 5p6, when you look it up, is xenon. So I am going to put xenon into the brackets, followed by what comes after the xenon, which is the final part. 6s2, 4f14, 5d6. Now, the final part of this is showing the orbital notation. And for the orbital notation, you are going to show one orbital location for the s's, 2, 3, 4, 5, 6, 7 for the D's, and 1, 2, 3, 4, 5 locations for the F's. So, or sorry, yeah, for the D's, I said the wrong thing. All right, so then we are going to use our arrows up here to show what there is. And I can see that there are 2 electrons already in the S. So I'm going to copy those and paste those right in here into the S location. And then I can see that all of my F's are filled up. So I'm going to paste those all into their locations here. I'm going to repeat that over and over again. Yes, I know this is a little bit labor intensive, but you're going to be okay. And finish that here. Now, where the decision making has to come in is how are the electrons going to go into the D sublevel? And please remember that what happens is the electrons separate first, and then only if there is no more space are we going to put them into a pair. So I start with separating my D electrons. The first 5 are going to go into the orbital locations by themselves, and only the final electron will pair up in the very first place. So I'm going to show that final electron right here, paste it in, and there I have my S, my F and my D orbital locations. To answer the question, what is the number of unpaired electrons? In this case, I have 1, 2, 3, 4 unpaired electrons. So I can say there are 4 unpaired electrons. Okay, everybody. That is how you do your work for electron configurations.